Okay, so now I'm going to walk us through how to solve an A-level kind of question. So I've drawn the picture already, and I'm going to fill in the KU-EQ table as I read the question. So we're going to call this the horizontal information up top. And down here, the next row, we're going to call this vertical information. All right. So it says, a goalie kicks a soccer ball downfield with an initial velocity of 15 meters per second at 37 degrees, measured from the ground. Neglect air resistance. How long is the ball falling through the air? Oh, so we need to know time. And the time in the horizontal is the same as the time in the vertical. And how far away from the goalie does the ball land? Oh, and then a horizontal change in position. Okay, so what do we have here? We have a goalie that kicks a soccer ball. Initial velocity is 15 meters per second at 37 degrees. Whenever I'm given a velocity, vector, quantity, and an angle that's not perpendicular to the direction, that's not along the horizontal axis or not along the vertical axis, it's like at an angle, like what I'm drawing right here. So this is 15 meters per second. And then the angle, theta, is, and given in this one, is 37 degrees. So whenever I'm given an initial velocity vector that's a magnitude of a vector, an angle that's not 0 or 90 degrees, or it's not due north, due south, east, or west, then I'm going to have to take that vector and I'm going to break it up into its horizontal, this is Vix, and its vertical components, Viy. And then we're going to use our favorite trig functions to come up with the relationship. So let's do the horizontal one. So because this is the adjacent side here, and we know an angle and the hypotenuse, we can write a relationship Vix equals the magnitude of the vector times the cosine of the angle. So that's 15 times the cosine of 37. And then the vertical component, Viy, is the magnitude of the vector times the sine of the angle. So then this is 15 times the sine of 37. Okay, so now I'm going to do a little calculation in there and then pretty much figure out what the next answers are here. So let's fill in what we know. So now I'm going to put this into our table. So the initial velocity in the x direction is 15 times the cosine of 30, 5 times 3, 4, is 12. I'm going to round to the nearest whole number, 12 meters per second. And then the acceleration is 0 meters per second squared. Final velocity in the horizontal is also 12 meters per second. Okay, because it's moving horizontally and there's no pushes or pulls in the horizontal direction. And then if we want to figure out delta x, we're going to use the GPS equation. Delta x equals 1/2 at squared plus VIT. In the vertical direction, we know the initial vertical velocity, Viy, is equal to 15 times the sine of 37, which should be 9 meters per second. The acceleration is -10 meters per second squared. And we don't know time. Oh, our final velocity is -9 meters per second. And so if I'm looking carefully here, I know that I have final velocity in the y equals g times t plus initial velocity in the y. We've used that equation before, and so I'm going to use this speedometer equation to figure out time. How long is the ball in the air? So when I plug that in, I have to make sure I'm very careful to what I said my values are, including the signs on them. So final velocity in the y direction is a -9 meters per second. And then we have negative 10 meters per second squared is the acceleration of our falling object, which is the soccer ball. And then time is what we're solving for, plus the initial horizontal component is 9 meters per second. So then I'm going to do a little algebra. So this is minus 18 equals minus 10t, which implies that t is equal to 1.8 seconds. All right, so that's part one, or part A, sorry. How long is the ball falling through the air? And so that's part A. And now part B is how far away from the goalie does the ball land? So we already know the total time it spends in the air. So that's what I'm going to plug into my equation here. I'm going to plug in this value for time. So let's see what we got. We got delta x equals, so acceleration is 0, 12t plus, oh, sorry, I'm like zoning out here. I'm sorry. So acceleration is 0. So then I'm just going to put in the horizontal component of velocity and time, which is the horizontal component of velocity is 12 meters per second times time. And the time that we recorded earlier is 1.8 seconds. So I'm going to plug in and check on my calculator 12 times 1.8, and I get 21.6 meters. So there's my second answer. So I've got 1.8 seconds is how long the ball's flying through the air, and then 21.6 meters is how far away the ball lands from the goalie. All right, so it's still all the same assumptions. The thing that's different about this problem, the launched at an angle compared to the horizontally launched, is first that this one has a vertical component of velocity, and that we might have to use different equations to solve for the requested quantities. All right, there's lots of extra practice on Canvas. Good luck.